This is the video for lesson 10.3a, operations with radical expressions. Today we're going to look at how to add and subtract with square roots. It's a lot like combining like terms has been all year. So we're going to look at that right now and talk about what happens if the square roots are the same and what happens if they're not the same. Before we do that, a little bit of final review. So the first one says solve, and it has something that's already factored for us, x plus 12 and 2x minus 10. Well, this is that zero product property. There's two possible values of x here that I could plug in and get 0 out. So remember, if something times something equals 0, either this has to be 0 or this has to be 0. So one possibility is that x plus 12 equals 0. Subtract both sides by 12, and we get x equals negative 12. So that's one of our solutions. And then our other possibility is that 2x minus 10 could be 0. So this one will be adding 10 to both sides and dividing by 2. Our other possibility is that x equals 5. So that one has two solutions, one at x equals 12 and negative 12, and one at x equals positive 5. Second one just says factor. Probably the one thing you should definitely take away from this class is how to factor. Remember that when there's a number out front and we're not able to get a GCF out of there to get the number in front of the x squared gone, we have to look at the factors of the front and the factors of the bottom. So I'm just going to rewrite this because it was kind of scrunched. But 2 times 1 is the only way to get to a 2. And then 6, we can either do 1 times 6 or 2 times 3. When all the signs in a trinomial are positive, it factors into 2 plus signs. We have to use 1 2x and 1 x because those two need to multiply to 2x squared. Since I want to get to 13 in the middle, I think about what do I want this 2 to get multiplied by. If I multiply it by the 6, meaning putting the 6 here, then those two multiply to 12x, and then I can put a 1 here. 12x and 1x will make 13x. So this would be the factored version of the trinomial at the left. Okay, so that's the final review into today, adding and subtracting these radicals. So first week of the semester, we talked about combining like terms a little bit. 3x and 5x, we can say are 8x. Okay, since these two have the same variable and the same exponent, we can add the 3 and the 5 and we can say that that's 8x. It works exactly the same way with square roots. So square root of x and square root of x, that's the same base with technically the same exponent. So as long as they're both a square root with exactly the same stuff underneath the square root, we can say that this is 8 times the square root of x. Okay? The square roots have to be a perfect match, but then you're able to add or subtract the numbers in front of the square root. We wouldn't change on anything underneath the square root, just like we didn't change the x in the first problem. So it says to add and subtract radicals, you must have, and I'm just going to write like terms in here. Okay, just like we've said before, which means that the radicands must be the same. So the stuff under the square root must be the same. They have to be the same under the root. Okay? If they're not the same under the square root, we'll do some more examples in a minute. If they're not the same radical, then you're not able to add them together. Okay? This says radicals can only be added, subtracted if when each term is simplified, the radicals are the same. Okay? So this is a little bit of a hint. If the square roots aren't the same, maybe if you simplify it, they become the same. So let me show you this way. So we have 6 plus square root of 2 plus 2 square root of 8 minus the square root of 18. The 2, the 8, and the 18 are all different this time. So since they're all different, I can't add the numbers outside. We can't add the 6, the 2, and the negative 1. Okay? We can't combine those because all of them have different square roots. However, if you look at 8 as 4 times 2, and if you look at 18 as 9 times 2, well then through some simplifying, you can get to this step down here, where all of the square roots have a 2, just a 2 underneath. Then, in that situation, I can do 6 plus 4 minus 3, which is 10 minus 3, which is 7, and then I have my square root of 2. So it is possible to add them together if they start off differently, if the radicands start off differently. But maybe you can simplify them down and they end up being the same square root after all. So we'll look at a few examples, and then this video will go pretty quickly here. The first group here, they have the same radicals already, so there's really not a lot to talk about for these. We have 6 and we have 9. We're going to add those together and get 15. And then the square root does not change for these. When you add or subtract, the square root stays exactly the same. Okay, this one, think of this as a 1 and a negative 5. Okay, 1 and negative 5 should make negative 4. We have negative 4 times the square root of 3. All right, a couple more times. We have 7 and negative 8. Those make negative 1. And then we have square root of 2. If you wrote this without the negative 1, that's fine as long as you have the negative symbol. And then the last one is just 5 plus 2. So this is 7 times square root of 5. And what we need to talk about a little bit more is if they're not the same, but hopefully that part of the video is making some sense for you. Okay? If the radicals are the same underneath, then you can just add or subtract right away. No other steps. If the radicands are not the same, okay? If they're not the same, just simplify it first. Sometimes it doesn't help you. Sometimes you still end up with stuff that's not the same. But a lot of the times on these, you end up at least being able to combine some of the things. So, in this one, we have 7 and we have 28, and those are different. The square root of 7 can't be reduced anymore because there's no perfect factors that go into 7. But the square root of 28 can be written as square root of 4 times the square root of 7. Okay, 4 goes into 7, or 4 goes into 28 7 times. So what we get here, I didn't change anything for the square root of 7 out front, but I have 4 square root of 7 plus 2 times the square root of 4, which is 2, times the square root of 7. And that's equal to 4 square root of 7 plus 2 times 2, 4 square root of 7. And now these match, so I can add them together and get 8 square root of 7. So simplifying first allowed me to to realize that the square roots underneath are the same, which means I can add them together. All right, last one, 32 and 18, they don't match, okay, but they both have factors that are perfect squares. So we have 5, we can write square root of 32 as square root of 16 times square root of 2. And then we have a 4, we can write 18 as square root of 9 times square root of 2. And then we can just evaluate those perfect squares. We have 5 times 4 times square root of 2 minus 4 times 3 times square root of 2, which is equal to 20 times the square root of 2, 5 times 4, minus 4 times 3 is 12 square root of 2, and now these 2's match. So 20 square root of 2 minus 12 square root of 2 is 8 square root of 2. So again, the square roots started off not the same, but after we simplified, they ended up being the same. And that's it for the 10.3a notes. Looking into tomorrow, we'll be looking at maybe a little bit of foiling or distributive property with these square roots. But until then, go ahead and try the assignment. Good job.